So what is motion? Motion here, let's see what is motion. Like you said, it is the change of an object's position as time passes according to the position of another object. What does it mean? For example, there's a tree here, okay, and I am standing here. Malak is standing here, all right, and like I'm asking, after 3 minutes, what would be the position of Malak? She will be at the same position it will be in the same position A, or she will be in another one. She will change her position. Yes, if she is here after 3 minutes, it means that she moved because she changed her position according to the tree. Now she is away from the tree, right? So what is motion? It is the change of an object's position as time passes according to the position of another object. According to the position of another object. What is the another object here? It is the tree. Okay. Let's see what is the simplest type of motion. What do you think? What would be the simplest form of motion? Yes, Malak. What?
To move like small distance.
To move what?
A small space, like.
Small distance, you mean? But it's not about simple here. You are speaking about the distance, not the motion itself. The motion itself, if I want to say about the motion itself, it's simple. It means I need two conditions. So I can say about this motion is simple. I need two conditions. What are they? It must be in one direction and it must be straight. Like what? The easiest example. Very good. Yes, very good. It's like the train. The train moves in one direction. This direction, it can be straight like you can see here, or sometimes even if it's curved, but still it is moving in the same path. So the motion in one direction, like the train, moves only forward or backward. Can the train go up or down? No.
Teacher.
Yes,
it has like
only
a road like this.
Yes, it moves only in one direction. Okay. And what is the other one? It's straight. The path of the train is straight, so the movement of it will be straight in a straight line in one direction. So again, what is the two conditions? So I can say about the motion, it is the simplest type of motion.
In one direction and straight.
Yes, it must be in one direction and straight. So I can say about it is the simplest type of motion. So what is the simplest type of motion, Mirna?
Motion. The definition of motion
is what is the simplest type of motion?
Motion, like it means that the action or process has.
We said there are two conditions, so I can say about the motion it is in a straight line. What are they?
I guess motion is a straight line and motion in curve.
No, motion in a straight line and in one direction. In a straight line and in one direction. How about speed? What is the speed, or when can I say about an object that it is going fast? When I can say about that Malak is faster than Mirna, when can I say that?
Regarding my distance is more than hers. Yes, and the time.
Yes, this is an important thing. Yes, in the same time. For example, here we have Malak and Mirna. So if both of you, I give you 3 minutes, both of you. So, for example, Malak reached here after the 3 minutes, but Myrna here, she took 100 meters, and this one only 40 or 30 meters. So it means which one is faster than the other? Of course, the first one, or Malak is faster than Myrna. Why? Because she covered more distance in same time. So it means that the speed depends on two factors that are distance and time. Distance and time. So what is speed? It is a physical quantity that is used to describe and to compare the motion of the object. I use the word speed to describe and to compare motion of objects. I can compare which one is faster than the other, which one is slower than the other. So I can say the objects either fast or slow related to their speed. Okay, so here there is an example like we just said. If we have two cars, one that is red and the other one that is blue, so when I can say about each one of them is faster than the other? Here both of them moved in the same time. Here the time is the same. Time is 0.05 seconds. So it means that both of them took the same time, but the red car reached 100 meters and the blue car 50 meters. So which one is the faster than the other?
The
red one. Here they are covering the same distance. The red car took 0.5 seconds, but the blue car took 10 seconds. It means this one 5 seconds, this one 10 seconds. Which one is faster? Red. Why? Malak, tell me, give reason. The red car faster than the blue car in this case.
Less time, same distance.
Yes, because they covered the same distance but with less time. It took shorter time. Very good. So we have two factors that are necessary to describe the movement or the motion, or the speed or the movements of the speed or the speed itself, the distance and time. So I can say, what is the speed? The speed is the distance covered in a unit time. The distance covered in a unit time. Or I can say it is the rate of change of distance. It is the rate of change of distance. So let's take the law and how can we calculate it? If the object covers a distance, the distance symbol is d. Distance d, okay? Time t. Time t. And the speed, we are writing the speed v. We are going to take it later, inshallah. V is the symbol for velocity. Velocity is the speed, but with direction. So we have here distance d, speed v, and time t. How can I calculate it? What is the law? I'm using velocity or speed equals d over t. So the speed equals d over t. So I have here the speed v equals d over t. How about if I want to calculate the distance?
It will be speed times the
Very good. Time. Speed times time. If I want to calculate time?
Divide. Speed divide distance.
Yes. Distance divide speed. Distance divide speed. Okay. So if I ask what that meant by, a train covers a distance 240 kilometers in 2 hours. Myrna, what is meant by a train covers a distance 240 kilometers in 2 hours? You are going to define speed. You have distance and you have time. So what is meant by? It covers 240 kilometers in 2 hours. Okay, Malak, do you know?
Yeah, teacher.
What?
It will be that the distance is 200. It means that the train covered the train moves a distance with 240 kilometers, and the time is 2 hours.
But it's just written the same. We have to change it. You can calculate the speed, for example, right?
Yes.
What is the speed? How can I calculate it?
Velocity equal distance over time.
Very good.
Equal 240 over 2 hours.
Very good. So it will be 120. Very good. So I can say that the train moves with a speed equals 120 kilometers per hour. How could I know this unit? From where did I bring this unit? He gave me already kilometers. So it's here, kilometers of the distance. And they are 2 hours. He gave me the times hour. So like I'm dividing distance over time, I'm dividing the units, kilometers per hour, kilometers over hour. This is the unit for the speed. So it will be kilometers per hour. What is meant by a car moves with a speed 150 kilometers per hour? Merna, try this one. He gave you here the speed, so you can make it like distance and time. Yes, Merna, are you here?
Yes, teacher, I am here. A car
Yes.
moves the speed 150 kilometers per hour. We will do 150 over 1.
Okay, so you can say that it moves 150 kilometers in 1 hour, right? So we can say that the car covers a distance 150 kilometers in 1 hour. Yes, very good. Okay, Malak. The speed of a car equals 0. What does it mean?
It means that the car is in its static form. It doesn't move.
Excellent, excellent, very good. It means that the car is at rest. It is not moving. So the car is at rest. We are using this word at rest. It means it is not moving. For example, the car is parking or whatever. Here they are asking when the following happens. When the amount of the object speed, when the speed equal the amount of the distance covered. Let's see if you can think about it. When can I say that the speed equals the distance? Like if the speed 100 and the distance is 100, when can I say that? The amount, they are asking here about the amount.
Teacher, you mean now they are asking about the time or what?
Very good that you are thinking about the time. Okay, think about the time. When the time is what? They will be equal. The speed and the
When
distance.
the time is it will be the time. It will be 100 divided 100. It will be 1.
Excellent, very good. If the time is 1 hour or 1 minute or 1 second, any one. If the time is 1, the amount of the time is 1. It can be 1 hour, 1 second, 1 minute. So the velocity amount or the speed, sorry, amount equal to the distance amount. Jana, how are you, Jana? Just joined? Jana, can you hear me? Okay, we have here give reason. The object speed increases by decreasing the time taken to cover a certain distance. Give reason. The object speed increases by increasing the time taken to cover a certain distance. Why? Let's think about it. First of all, if I have any like questions like this, and I know already that I took a law in this lesson or in this part of lesson, I have to write the law. What is the law that I can write here?
Distance equal. First, I'm gonna think about it.
Okay, V equals what?
V equal the distance over time.
Okay, so they are asking why when the speed increases, this.
Joe, but I have a question.
Yeah.
Why did you like put the velocity in front and you are gonna calculate the velocity?
Sorry, I didn't hear. What?
I mean, why you don't calculate the distance or the time?
I write it is the speed equals the distance over time.
Okay.
What?
I understand now.
Okay. Here they are asking why when the speed increases or why the speed increases when the time decreases. Okay.
Inversely proportional?
Yes, very good. Yes. If we have like, we are going to add one here because it's anything, any whole number, anything that has nothing here. So we have one in under it. We can imagine that. So we have here the relation between all that above here. They are directly, like when the distance increases, the velocity increases or the speed increases. But here they are inversely proportional. When the time decreases, the velocity increases. So I'm going to write the law and tell them that because the velocity or the object speed inversely proportional to the time taken when the distance is fixed. So when this one decreases, the other one increases. The other question, the object speed increases by increasing the covered distance at a certain time. Already we know how to answer this one. Yes, here they are directly proportional. I'm going to write the law and tell them. So because V equals D over T, so the speed is directly proportional with the covered distance when the time is fixed. Any problem here? Or is it clear?
No, it's clear.
Clear. Marna Ndajana, if you are here. Is it clear? Okay. The measuring units of the speed. The measuring units of the speed. The speed measuring unit is different according to whatever he give me in the problem. So I'm going to use the units he gave it to me. He gave me for example, the train moved 50 meters per second in 1 second. So I'm going to use the speed for meter per second. He give me meter and minute, so meter per minute. Kilometer an hour, so kilometer per hour. Kilometer per second, whatever he give me, so I'm going to use the same unit he give it to me. How about if he asked me to calculate the speed with a specific unit? So I need to know how can I change from one unit to another. You took it before, so let's revise it together. Converting units. I will tell you very, very easy way to convert from unit to another. So for example, I'm going to write here kilo. Meter. Here I'm going to write meter, and here I'm going to write centimeter. Here I'm going to write it's 1000. Okay, and here I'm not going to write anything. Here I'm going to write it's 100. Sorry, 100. Okay, so if I want to change from kilometer to meter, what I will do?
It will be divide. No, it will be times 1000.
Of course, it will be times. If I have the kilometer in the left side of my equation, in the left side, so I'm going to write it as it is, 1000. If I want to change from meter to kilometer, if kilometer in the right side, No, yes, it will be divide. It will be 10 power negative 3, or it will be divide. That's it. So I know now kilometer, 1,000 meters. So from kilometer to meter, it is, I'm changing from the big one to the small one. So I need to multiply it so they will be equal. I'm changing from the small one to the big one, so I need to divide it so they can be equal. It is the same here. From centimeter to meter, what I'm going to do?
From centimeter to meter, it will be divide.
Excellent.
100.
From meter to centimeter?
Times.
Yeah.
Times.
Multiply or times, very good. It is the same. We have another thing about the time. If I want to change from hour to minutes, multiply or divide? Hour to minute. From big to small, multiply or times with 60, because the hour has 60 minutes. Okay, if I want to change from minutes to seconds,
It will be multiply.
Yes, multiply 60 as well. If I want to change from hour to seconds,
From hour to seconds.
multiply 60 times 60, so it will be multiply 3,600. So if I need to change from hour
Can
to
you
second,
explain the last one?
yes, the last one. Here I know that if I want to change from hour to second, so I need to multiply by 60 to change into minutes, and another 60 to change into seconds. So 60 times 60, 3,600. Okay, you can just know it, this information, from hour to second, 3,600. Okay, and the opposite, you are just going to divide. From minute to hour, divide 60 second to minute, divide 60 second to hour, divide 3,600. Okay, there is another one that is already calculated. You are just going to study it like as. Yes, Malik, sure.
It will be 120 times 120 seconds.
What?
Correct? I mean the last one. The last one. Is it gonna be times 120?
120?
Yes.
No, why? You are going to make 60 times 60. 6 times 6, 36, and 0, 0.
So not plus.
No, not plus. It's times.
Okay.
Yeah. Okay. How about if he give me, it's for example 12 kilometer per hour, and I want to change it into meter per second. I want to change it from kilometer to meter. What I'm going to do?
It's going to be divide. No, multiply, teacher.
Multiply with what? Multiply by what? Okay.
1,000, teacher.
1,000 over from hour to second. What is it?
60.
What?
No, teacher, it will be 3,030.
Yes. Now, if we simplify this, it will be times 5 over 18. 5 over 18. So this number, you have to study it and keep it in your mind. If I want to change kilometer per hour directly, I'm going to multiply by 5 over 18 to change it into meter per second. If I want to change it from meter per second to kilometer per hour, I'm going to divide over 5 over 18. Okay? Let's answer some problems to practice about this. A runner runs at a speed of 6 meters per second. Find the distance covered by the runner in 10 seconds. What I'm going to do.
Can me answer?
Yeah. Jana and Berna, are you here? Because they are not picking up. Okay. Yes, Malak.
A runner runs at a speed of 6 meters per second. Find the distance covered by the runner in 10 seconds.
So
it will
distance
be
equals?
the speed equal, it will be 6.
You have to write the law first, Malak. What would be the law for the distance?
Needed the distance, so it will be distance equal time times velocity.
Velocity times time. Very good. So it will be
The speed is 6 times 10.
it will be
Equal
60 what? 60 what?
60 meters per second.
Meter per second is the unit for speed. I want
So
distance. Meter. That's meter. Very good. Okay, a train covers 50 meters in 2 seconds. Find its speed in kilometer per hour. So first, let's calculate the speed. The speed will be?
it will be distance over time.
Okay.
Equal 50 over 2.
So it will be 25 what?
I mean, speed, it will be meter 2 seconds.
Yeah. So change it into kilometer per hour. So I want to change it into kilometer per hour.
Times 1000.
Focus from small to big or from big to small?
No, it will be from small to big, so divide.
Yes, divide over what?
1000.
1000? I'm changing kilometer per hour. 2 meter from meter per second to kilometer per hour. The number that
So
we just took now.
1000
5?
and wait, teacher, second.
Okay.
It will be 1000 and
yes. We said
and
what?
300. It will be 1000 and 306.00.
Yes. So we just said it's 5 over 18, right?
Okay.
Yes.
Correct.
Then you are going just to calculate it on the calculator. Okay. Let's make this one. A plane moves from Aswan airport and covers a distance of, so we have distance equals 850 kilometers. In time, 1 hour. To reach the Cairo airport, calculate the speed at which the plane moves. First in kilometer per hour.
It will be, the speed will be velocity equal distance over time.
So it will be already
distance over time.
Okay, distance 850 and time 1. So the speed will be
850
what? 850 what?
kilometer per hour.
Okay, so we already made the first one. The second one you wanted meter per second.
So it will be from big to small.
Yes.
It will be wait, teacher, wait a second. From big. It will be times 1000.
Malak. Yeah, Malak. Allah ya Malak. I'll be sad now. It's a kilometer per hour.
No, teacher. Just it will be 18 over 5.
5 over 18. No
Yes.
problem, because it's the first time you hear the numbers, so no problem. I forgive you. It's 5 over 18. 5 over 18.
And
okay.
The kilometer, it will be divided, and the hour, it will be 3,600.
Okay, very good. Last one. A train starts to move at 6 o'clock in the morning. Then, what is the time of arrival? Look here. He is not asking about like how many seconds. He is asking what is the time of arrival. So you need to write which o'clock, which time. If it moves at speed of 40 kilometers per hour to cover a distance of 20 kilometers.
So I will find the time.
Okay.
Time equal the speed over the distance.
Okay.
40 over 200.
Are you sure about this?
No, it will be
Okay, let's draw the triangle.
400 over.
No. Let's draw the triangle so you'll not ever be confused, ever. Here the t of the time, yes, and we have here v and t. So t equals?
Equal the distance divided by the speed.
Yes, very good. So distance
400
is
over equal 50.
Equals 5.
Kind of how? Oh, okay.
Okay.
Then it will be 5 hours.
5 hours. So what now? Did we answer the question? Still something we didn't do. Time of arrival. The time of arrival. I need to know at which o'clock. So he took he started, look here, start moving at 6 and he took in the journey 5 hours. So he reached at?
So after 6, 7, 8, 9, 10, 11. It will be 11.
Excellent. 11 o'clock. Very good. Yeah. In the morning as well. Very good. We have Ruqayya and Ziyad. You just joined. Ruqayya. Okay. So time for answering questions. No, before the types of speed.
No, teacher, I will answer with you.
Thank you for not letting me go.
Yes, you want to answer some questions.
Yeah, sure. But anyone else will share with Malak?
Me too, teacher.
Finally, welcome back. Okay, Mirna will answer with you. Anyone else? Jana or Ruqayya? Ruqayya just joined. Okay, let's have it like with and
It will be Malak.
Malak and Mirna. Okay, Maluk, choose a number.
I will choose number 10. It is straight.
What?
It will move in a straight.
Yes, the type of movement. It is. Yes, it moves straight, but it is the simplest motion because he asking about the type of motion or the type of movement. I'm sorry, Wallah, I didn't mean to open the answer. So it is the simplest motion or the simplest type of motion. Okay? Remind me with the two conditions. I will make it correct for you.
Okay, the two conditions. It will be a straight. In a straight motion, in a straight line, and also it will be in. Wait, teacher, I know it.
Okay, take your time.
And in one direction.
One direction.
One direction.
Okay. Mirna. Very good.
Yes,
what's your number?
4.
In electric. What?
I'm just going to, yes. Should I do the question?
Yes, okay.
In the electric discharging experiments through gases, cathode rays deflect away from the metal plate, which is negatively charged because they are...
I'm sorry, this question is... no, it's not for this lesson. So I'll change the question for you. Okay, tell me what is the law for the calculation of speed?
Speed, distance over time.
Yes, distance over time. Okay, Malak.
Okay, teacher, I will choose number 1.
Physical quantity that distinguishes the description of objects either fast or slow.
It's fast or slow? Speed.
Very good.
Or the below.
Yes, Myrna. Myrna, are you here? Myrna? Okay, sure. I will pick number 3. And what is meant by a train covers a distance 200 kilometers in 2 hours? Yes.
What the meant by one A covers a distance in 2 hours. That means that what teacher, what one E will A, what is
No, just ignore it. It's a train. A train covers a distance 200 kilometers in 2 hours.
that means the distance of the train 200 kilometers in 2 hours.
You said it the same. We have to use these numbers in something.
Should I calculate it?
Yes, sure. How can we calculate it? What
We will
are we
do
going to
200
calculate?
the distance over time.
Okay, what is this? What is this that equals distance over time?
Speed.
Speed. So it will be
100.
yes, 100. Very good. It means that the speed of this train equals 100 kilometer per hour. Yes, Malak?
Number 7.
7. The distance covered in a unit time.
It will be
What?
the distance covered in a unit time. So, a distance covered in a unit time.
Yes, what is it?
Teacher, you mean what is the word that defines this?
Yes.
It is the distance covered in a unit time. It will be the speed.
Speed. Very good, yes. Very good. Okay, Verna. Runza, you just joined.
Yes,
okay. How are you? You're in grade 9?
I'm fine. Yes.
Badly we finished the session. We are answering questions. Okay. Do you want to share if you know any information about the first lesson in science? Okay, Myrna, she didn't answer. Okay, here the question is, sorry. The total distance that the moving object covers divided by the total time taken to cover this distance. What is this? Distance when we divide the distance over time, like how much distance I need to cover in a specific time.
Teacher, is it minute question?
It's for the other team.
Okay.
If Runza, do you want to answer it?
Okay, ma'am, but 1 second, please.
Okay, sure.
Teacher, I'm with you. I was talking and my mic was... The total distance that the moving object covers divided by the total time taken covered distance.
Yes.
Ma'am, is the motion?
The motion is to change your position from one place to another according to another object. Change your place. But here there's a relation between the distance and the time. Like how much distance?
Speed.
Like excellent, very good. The speed. Should I put the points for the other time? It's the speed. Take it.
I would choose number
Yes, sure. Say.
I will choose number 9.
9. The
Change
change.
of object. Motion. Motion, teacher.
Excellent. Very good. Motion. Okay. Marna.
2.
It means that the object covers equal distance in equal periods of time. Okay, we didn't take this one yet. So let me ask you, how can I change? I have, for example, the speed of an object is 50 kilometer per hour. How can I change it to be meter per second?
Multiply 100.
100. Okay, it's multiply by what?
If we want kilo, teacher, for example, the number kilometer to meter.
Kilometer per hour to meter per second.
The 1 kilometer equal 1,000 meters.
Okay.
So we will multiply 1,000.
Only 1,000? How about the hour to second?
Teacher, I must do it all.
What?
Also the seconds we must do it.
Yes, for sure. How can I change it from hour to second?
Multiply 3,600.
Yes. So it will be 1,000 over 3,600. And we said that this number equal another number, a simpler form. What was it? If you remember. I think Malak remembers, right?
1,000.
You answered correct. Yes, if you divide 1,000 over 3,600, so it will be correct.
0.6.
Yes. Okay. Malak, what is the other number?
5 over 18.
Finally, 5 over 18. Okay. Very good. Okay, Malak?
Okay, I will choose number 8.
Okay. The simplest form of.
It will be straight and in one direction.
Excellent. In straight lines in one direction. And Runza, astaghfirullah. I don't know why the questions for grade 11. Okay, anyway, let me ask you. Okay, Runza, can you define the motion? Define motion.
It is the change of the object location from one place to another according as the time passes.
Yes, excellent. According to a fixed position.
You must ask a hard question, and who will answer it will win.
Good idea. Yes.
Somebody can win.
Right. So we can make like a question. The one who will answer it first will win. Okay?
Okay, ready.
Ready. Okay. I'm opening the whiteboard and I'm going to draw something here and you are going to tell me what I'm drawing.
Is it gonna be calculations?
No.
Okay.
Sorry. If you understand why you are okay. The question would be, this relation would be with the velocity with what?
It will be velocity with the distance.
Yes, very good. It will be velocity with distance. Okay, let's explain. Yes, you won. The relation between velocity and distance is is directly proportional because V equals D over T. So here both of them if the distance increases, velocity increases as well if the time is fixed. So we have here when the velocity increases with the distance when it increases. So this when we draw in the graph the line in this direction, it means that is direct relationship. How about if I want to draw it indirect relationship? Look here, when I'm, for example, I'm writing numbers so you will understand it more. So 1 increased, it will be 1. 2 increased to 2. 3 increased to 3, and so on. Here I'm going to draw the inversely proportional. I have also 1, 2,
So it will
3.
be velocity and the time.
Yes, very good. So here I have velocity and time. When the time increases, here the velocity was 3. Time increases, no, the velocity decreases. Time increases, 2, 3 increases to 1, the velocity. So this one is inversely proportional. Yes, very good. Did you take these things in math before or not yet?
Not yet.
Yeah.